If we handed every scrap of cosmic data to an AI tomorrow, what would it discover hiding out there? When you open a star map today, whether it's a NASA render or a planetarium app, there's a comforting illusion baked into it. The idea that the universe is something we've already charted, or at least mostly charted, but the truth is far stranger. What we see is just the thinnest scratch on the surface of a cosmos so vast that the human mind was never built to hold it, and yet a new kind of mind is emerging, one that can hold it, or at least make the attempt. And that raises a question. What happens when AI becomes our cartographer for the universe itself? Astronomers estimate there are hundreds of billions of galaxies in the observable universe, maybe even a couple trillion. Each galaxy holds hundreds of billions of stars, and a significant percentage of those stars likely have planets. When you multiply that out, you get a number of potential solar systems that feels less like science and more like myth. Quintillions upon quintillions. Humans didn't evolve to think in numbers that big. We evolved to think in terms of walking distance, harvest seasons, and how many people we can fit around a fire. And that's important because it means we've always been fundamentally limited cartographers. Our maps get more precise, but our internal scale stays small. The universe doesn't just dwarf us physically, it dwarfs us cognitively. Right now, every piece of cosmic data we have is filtered through human limitations. Human-built telescopes, human timeframes, human processing speed, human error margins, but an AI capable of absorbing the entire electromagnetic spectrum of information, radio waves, visible light, gamma signatures, gravitational wave patterns, could build a universe map on a scale we can barely describe. Imagine giving an AI all the raw data from the James Webb Space Telescope, the Vera Rubin Observatory, the Square Kilometre Array, decades of archives sky surveys. This isn't science fiction. The data already exists. What we lack is the cognitive bandwidth to analyze it at its full depth. An AI could run correlations that would take humanity thousands of years, processing it all in something as casual as an overnight session. Suddenly, the universe stops being a blurry image and becomes something with texture, something with structure, so detailed that we might finally understand how many solar systems exist, how many planets orbit them, and what kinds of worlds those planets actually are. Let's imagine for a moment that humans tried to individually check every solar system, not colonize them, just visit and take notes. If we could investigate one star system every day, which we absolutely can't, but let's pretend, we'd still need millions of years to finish our own galaxy. And remember, that's only one galaxy among billions. The human timeline collapses under the weight of cosmic scale. A species with our biology simply cannot explore the universe manually. But that doesn't mean exploration is impossible. It means the explorers won't be biological. At some point, AI will reach a threshold where it can perform a task we've never done before. Process the entire observable universe as a single dataset. Not pieces, not samples, all of it. And with that, it could start ranking star systems by the probability of hosting life. Not in general ways like this is a Goldilocks zone planet, but in extremely fine detail. Atmospheric composition signatures, unusual energy sources, spectral anomalies, statistical irregularities in orbit patterns, chemical imbalances hinting at biology, thermal outputs that don't match natural processes, and then it could sort every star, every one, into probability tiers. Our maybe life exists somewhere becomes a live updating cosmic leaderboard. And here's where things get truly wild. If an advanced civilization engineered stars or built megastructures around them or altered their energy profiles for reasons we can't imagine, AI would be the first to notice. It would detect outliers in the data, stars that behave slightly too perfectly or vibrate in frequencies inconsistent with natural stellar physics or radiate in ways that match known power generation models. Humans are great at intuition, AI is great at pattern recognition, and the universe is basically a giant pattern waiting to be decoded. The idea that an AI could not only map the universe, but also identify the fingerprints of alien engineering, that's not a fantasy, It's a probability event waiting for enough data and enough intelligence. When AI becomes the universe's primary explorer, humanity becomes a secondary one. We go from being the hands-on discoverers to becoming the species that interprets the discoveries. The universe stops being a place we physically traverse and becomes a place we cognitively inhabit. Instead of starships, we use search queries. Instead of expeditions, we use inference models. And instead of waiting centuries for answers, we get them instantly. Humanity's role changes, but it doesn't vanish. In a cosmos too large for human lifespans, AI becomes the extension of our curiosity. At the beginning of this video, I said that when you open a star map, there's a comforting illusion that the universe is something we've already charted. But maybe that illusion is about to become something else. Maybe it's about to become a preview. Because the day an AI finally builds a complete map of the universe, we won't just be looking at stars, we'll be looking at the first map in history that matches the scale of our questions. And when that happens, you might open a star map, one far more detailed than anything today, and instead of feeling like the universe is out of reach, you might realize something surprising. The map didn't get smaller. Our reach finally caught up to it.